Hello and welcome to our case study, How Researchers Benchmarked LLM Emotional Intelligence with Prolific. I'm Sabrina, here from Prolific, to interview our two key researchers from the University of Bristol. So to start us off, could you both briefly introduce yourself and what it is you study?
So I'm a PhD student in my final year studying digital health and care, and my thesis topic has been trying to investigate the relationship between momentary mood and rewarded decision making. And Conor is one of my supervisors.
Yeah, so I'm Conor Houghton. I'm a computational cognitive scientist. I have a range of interests. Partly, I'm interested in effective state decision making in animals and in humans. And then, kind of related, I'm interested in higher cognitive function, in particular in language. So I'm interested in linguistics, the language ability, how that happens in humans, and what we can learn about it by comparing human linguistic ability to the ability of machines now to generate language.
And what then led you to exploring how you could benchmark AI emotional understanding?
Yeah, do you want to start with that?
Yeah. So throughout my whole PhD, I've been doing lots of experiments where we're trying to measure people's mood state through questionnaires, and then we also get them to do a decision-making task that looks a bit like Pac-Man. And part of those mood questionnaires, we've been collecting a lot of rich text information, asking people if a significant event has happened, which has led to their mood state at the time of completing the task. So we wanted to try and understand this text data in a better way than just, how many characters is it, or what are the keywords in it. So we decided to do a pairwise comparison tasks, where we compared two pairs of these statements and got human participants through the Prolific platform to compare which one of them they thought was worse, to try and create a ranking system for the kind of degree of badness of these subjective events that people had reported. So that's kind of where it started. And then because of kind of timing issues and our other interests in large language models, we then decided to see if they were capable of also doing this task.
I mean, I think there's a bigger sort of plot as well, which is, when you're interested in cognitive tasks, in the past, there's always been this pressure towards making the task, decision-making task, or whatever sort of task you're designing, trying to make it as exact as possible. We ask questionnaires, but when we ask questionnaires, we ask people to rate things 1 out of 5. We do experiments with animals, and we ask them to do the same task again and again and again. We do psychophysics with humans. We ask them to do this very precise task. And of course, the worry there is always that you're studying their performance on a particular task or studying them in a particular context that's not ecological, that doesn't have so much to do with how people behave. And so when you're trying to work out things about people, you want to ask them questions. You don't want to ask them questions where they're answering A, B, or C, because that's not how people express themselves. People express themselves through language, or with animals. Their behavior is not possibly well typified by what they do in a box. It's well typified by what they do ecologically. With humans, it's something similar. So I think generally and sort of broadly speaking, we're interested in how we can evaluate stuff in a richer, more natural way. In that sort of transition, we want to work out, in this case, we have text data, qualitative data, we want to turn that into numbers. Ultimately, if we're doing modeling or testing some hypothesis, we need a set of numbers. And what we do need is some methodology for going from the sort of richer measurements, such as people writing down about events that have happened in their lives, to numbers that we can use in the sort of inferential or statistical frameworks we have usually brought to bear on these problems. And well, how do we do that? Well, what we came up with using these pairwise comparisons was a way of doing it. But how will we do it going forward? With every time to have to, ask people to look at pairs of statements and say which is better and which is worse, it would be nice if that could be automated. And we now have a real possibility of automating the evaluation of these richer tasks. In the case of these human data, that means feeding these statements to machines and asking them which one is more grievous. In the case of animal behavior, for example, in the future, we'll, the sort of stuff at the moment that we do by having people look at videos and note when an animal is freezing or whatever, we'll be able to do that by having the machine look at the video and point out the interesting behavior. It is going to become possible to automate these tasks, but we can't just trust the automation without also comparing them to human ranking or human evaluation in the meantime. So we were interested in both, the overall task, turning these complicated textual statements into numbers, and then we were interested in whether in future a machine could be used to do that instead. And I also think there's some basic fascination with the question, how good are machines at, what sounds like a very human question. Which of these two things is better? Which of two life events is a nicer or a worser thing? Obviously, humans can do that. The LLMs have the language models learned enough about us to make the same evaluation accurately. And we kind of thought that the answer would be yes, and it was to a remarkable degree.
Yeah, let's dig into a little bit about how we actually got to the end result here. So you started by collecting initial data on Prolific with humans. What did that look like? What was that study setup like? Who did you recruit? Can you talk me through that a little bit?
Yeah, so we ran the bulk of the data that fed into this later task was from 3 main studies. We recruited 18 to 30-year-olds because that's the age range of interest for the thing that I'm researching. And the studies were 3 very similar studies. They started with a momentary mood assessment, which was kind of 12 questions asking, between these 2 words, where do you feel your current mood state best sits? Through some attention check questions in there as well. And then they performed a task, as I said earlier, that looked a bit like Pac-Man, where you're foraging in these 2 different sites, looking for the cherries and trying to eat the cherries and avoid the ghosts.
It's a kind of effort for reward task. So there's 2 different sides, and one side is productive and the other side isn't, and you have to make some judgment as to whether the side you're at is just being unreliable or it's actually become unproductive. But to check the other side, you have to go through a kind of a mazy thing, controlling it with keys, which is supposed to be annoying. So are you willing to make the effort to potentially get bigger reward?
Yeah. And then after they'd done the momentary mood question with the words, we would then ask them, has an event happened that is significantly impacting your mood right now? And then that's where we got these longer text statements from. They had up to 500 characters to describe an event that had happened. Some of the responses we got were just 1 word. People were able to not answer that question if they didn't feel comfortable. And then some people did go into quite lengthy descriptions. So we had quite a varied data set on these events that people said were impacting their mood.
And from a more practical point of view, the game was written in JavaScript, so it took us quite a while to get it to work because JavaScript is, I think it's one of those things where one of those programming languages where you tend to think, I'll just give it a go, and you never really learn it properly. So you start with something and fiddle with it till it worked. But we were pretty pleased with it by the time we did have the game working. So the participants are recruited through Prolific. They're bounced over to our server. So we rent a GoDaddy server, basically, that we run these things on because it's easier than alternatives. And then the experiment consists of a series of different stages, some of it running on JS Psych, which is a platform for providing questionnaires, and then some of it actually running in this native JavaScript to produce the game, which is, Kimberley spent a long time getting to work nicely. It was based on an animal task. So we had a collaborator who ran a sort of similar task for rats where they're foraging, they're getting sugar pellets, and then they have to decide whether to walk over to another area, or to stay in the same place. Our feeling was it was a nice combination of different types of things. There was the effort bit, there was the rewardingness bit, etc. So that's where we started. We tried to think, me, Kimberley, and then Kimberley's other supervisors, Ian Penton-Voak, tried to work out a sort of human game equivalent. We thought people liked Pac-Man, although it's not very Pac-Man-like. The little carriage you play looks like Pac-Man, and you eat and you get cherries, but it's there's no ghosts chasing you or anything, so it's only slightly Pac-Man-like. Yeah. But yeah, in practice, we programmed or Kimberley, I should say, programmed in JavaScript the game to run on our server, and the participants were recruited from Prolific and then bounced over to us, basically.
Yeah. I would say the preliminary testing as well that we did also through Prolific, that did help with kind of fixing any bugs that we weren't aware of in the system, partly to do with sometimes multiple users trying to do the task at the same time. That was kind of a thing that's not very easy to test just as a single or a few researchers. And also sometimes if they're using different software than what we were using or different devices, then that's things that our participants thankfully flagged to us so that we could get all of that out of the way before we ran our full-fledged experiments.
And then once we had all of those data, we've been using them for various things. And the analysis is still ongoing. But one of the things we thought was it would be fun to try this ELO ranking to associate a number with these statements. And that was a wholly separate kind of thing that a wholly separate system. And that went kind of beyond the time we had to spend developing that application, because it's slightly complicated because you need the participants are all going and ranking the statements, but it's like a chess ranking. So, you're going from pairwise comparisons to an overall sort of measure of how good somebody is. But for the pairwise comparisons to be useful, the comparisons have to be between similar statements. You don't want to compare, I forgot my sandwich to I've just got married. You want to compare things that are reasonably similar in their effect. Exactly. Just like when chess players are playing each other, you don't want to have grandmasters playing beginners. It just doesn't produce a useful comparison. So we needed to have a single database that the different participants were interacting with. So that was quite complicated. So it's not something we couldn't have done, but it's something that we didn't have time to spend doing. So we found a computer science student basically to employ as an intern, and he spent some time writing that for us in a whole mixture of different programming languages. What he wrote was quite sophisticated. But again, we put that on our server and we took participants over from Prolific.
Yeah, I would add as well that was perfectly timed with a new feature that Prolific brought out, which was that you can limit the number of participants that can do the study at a given time. Because our server, we were concerned that it might have some limitations on how many people
we don't pay that much for our server, basically. We're only now 10 people interacting with it at once.
So I think it was about a month maybe before that I saw that feature was added, and I was like, well, that's just perfect. So we were able to cap our participants coming in.
And it also made it less like it was simultaneous. There was a shared database that gave the current score of the different statements to decide which pairs to pair up. We didn't want too many people trying to use that at the same time as well. And again, being able to throttle the participants coming over was useful there.
Nice. Glad to hear that. Definitely glad to hear that. Could you talk me through a bit more about the types of examples? So I think you said, you forgot your sandwich today, or you got married today. What were the types of things that people were experiencing that eventually you used for the benchmarking?
Yeah. So I think a key part of the question was, is an event significantly impacting your mood right now? But obviously people can interpret that in any way that they want, and it wasn't up to us as researchers to judge what something significant was to a participant.
I mean, it's kind of what we're measuring in a way.
Yeah. So some of them were things like, they weren't all negative, just to highlight that as well, but I would say that about 66% of them were negative statements, and they would be things like I dropped my phone today, and then some positive ones like expecting my fourth child, things like that. There were some of them were quite difficult to read. Some of them were very sensitive descriptions of events that are very difficult to deal with in life. There was quite a lot of reporting of kind of death events and things around that nature, which I wasn't expecting there to be that many of those events coming through from because it was only, total it was about 900 to 1,000 participants that we did through the first 3 studies. And of the ones that reported events, there was about 350 text statements that we got. So then of those, I think there was about 20 to 30 that were reporting kind of death events, which was quite surprising.
Near relatives, friends, people they knew who died or had terminal diagnoses. So I mean, the very nicest ones it makes you happy to read them. People saying they've just met somebody new and they love them so much, or they've just got engaged and they can't wait to spend their lives with these with their partner, etc. Then all the stuff in the middle, late to work, aggro work, lots of stuff with work, commuting, etc. And then it's at the negative end, as Kimberley says, really terrible things happen to people, and how you go from there to a score is kind of the difficulty. You want to take these things, and obviously it's easy to say, a nice thing is nice and a bad thing. Well, a very nice thing is nice and a very bad thing is bad. But turning that into data, quantified data, you need some method, and then the method that we used was these ELO rankings, basically pairwise comparisons, and turning them into scores.
And I think that also highlights one of the good uses of trying to get AI to do this task. is that I did put a trigger warning, again, which I think is one of the newer features of Prolific, and where you can advise people that there might be sensitive content in these tasks. Because of the sensitive content, you don't know the impact that that could potentially have on some of the participants. Obviously, you can warn them beforehand, but that does have one clear advantage for an LLM to be able to do this task, in that that's not going to be emotionally impacted and, carry forward any negative impact from reading these types of things that could potentially happen to a human.
Yeah, you wouldn't want to force people to do it day in and day out. I mean, just to give a little bit more explanation. I mean, we also asked the people themselves to rank these significant events, and so one interesting thing is, how congruent is their ranking of the significant events to the ranking, that the objective ranking coming either from the LLM or from the participants, and the question is that related to their affective state, or is there a phenomenon where people's affective state is so we have short-term and long-term evaluation of mood through standard questionnaires, the usual questionnaires that are used for a diagnosis. Then we have how they perform on this effort for reward task. We have their significant events, and we have their own ranking of the significant events. And we're still analyzing data, but the question is, how do these numbers all interact with each other? Is long-term mood a context or a consequence for what happens to you in your life? Is short-term mood a different measure, or just a complicated way about asking about long-term mood? How does it relate to how you make decisions, which is what the task is for? That's what we're interested in.
I'm curious to talk a bit more about actually how the AI benchmarks compared to the humans benchmarking. Obviously, we've covered all the ways that humans bring themselves to how they might interact with that data, and AI is very different, but how did they perform in comparison to each other?
I think, the simple statistical answer for that one is we did a correlational analyses on the final rankings that the humans produced, and then the final rankings that the LLM produced, and it was a 88% kind of similarity between those two. So that's quite high.
Yeah. I mean, broadly speaking, the human data was more noisy, the dynamics, because obviously as people make these comparisons, the different statements move around, and that seems to be, that sort of random walk effect seems to be smaller with the LLMs, even though obviously the LLMs do have a statistical aspect to their decision making. In fact, it's a tunable statistical aspect because you can change the temperature. But the answer, the end result was almost all the same. And we have tried to come up with a story as to when they were different, and that actually seems to be quite hard to do. So, there are a few statements that where the machine did seem to come up with different answers to humans. We thought that it had something to do with how long or how detailed people's responses were.
That was the bit that would have made the most sense, because as humans, we might not always want to read the most lengthy statements, and some of these were kind of paragraph length text. So the kind of one of the things we looked into initially was, okay, are the LLMs ranking the longer statements more differently to how the humans are ranking the longer statements? But that actually wasn't the case, and it in the analysis that I ran, it did seem that the longer statements had higher accuracy than the shorter ones. But again, you'll have more level of detail in those longer statements. So it might be a bit easier to try to distinguish between two very similar, ranked initially statements, and when there's more detail in them. But that did also kind of give us some, what's the word? It was very promising to see that our Prolific participants were actually reading the statements, even when they were very long, to be able to have this level of similarity.
Yeah, and it's funny because so one of the things is one of the statements, or a couple of times people said it's my birthday, and people ranking this seem very unsure as to whether that's a good or bad thing. The machine, I think, thought it was good news.
Much more consistent in the LLMs. Yeah, they have this is definitely better than this, whereas these statements are subjective in nature.
I think that's maybe the point, that the LLM was good at deciding whether events were intense or not intense, whether they were positive or whether they were negative. But the LLM kind of plumbs for a meaning, whereas humans, sometimes these statements have a number of different interpretations, and different rankers are interpreting them in a different way. When the LLM reads "It's my birthday," it imagines somebody with a balloon and party poppers going off. Whereas humans, some of them imagine that, and some of them imagine people sitting at a bar, thinking about the years gone by or the time running out or something. So, I think maybe the machine makes a decision in a way that maybe we don't.
On that, actually, I don't know if we've covered what model were you using to benchmark?
So we tried to go for the cheaper, more easily accessible models. Part of that decision was, well, if these ones perform well, then you would hope that the, later versions might perform even better.
I mean, they were kind of the standard models at the time, which is a couple of months ago. Yeah.
Yeah.
Okay, so 3.5, Claude 3.5 Haiku, Gemini 1.5 Flash, and GPT 3.5 Turbo. So I guess they're all now a generation behind. We're in the middle of a whirlwind.
Well, the Gemini one, it was free to use. So that one was actually very slow because there are limits on how much you can ask that to do. But yeah, the other ones would recommend. And they all ended up performing to the same level of similarity to the humans.
Ah, interesting. Now, what advice would you give to other researchers? I know there are a fair few researchers who come to Prolific to gather human data and then do things like benchmark it against other LLMs. You've gone through this process very recently, and you've covered a lot of different like data points and things you'd want to consider. I suppose what would be like the headlines? These are things you should absolutely be looking at when gathering that initial pool of human data and then when benchmarking.
Yeah, so I mean, overall, I guess the headline is that people are much slower to gather human data than maybe they should be. It's pretty easy, right? But I think that's one of the great things about psychophysics moving online. I'm quite sort of bullish about it. I feel that online participants, people worry about their level of attention, whether they're multitasking. My own feeling is that that's producing actually more ecological results. Now, obviously, for classification tasks and so on, you do have to bear that in mind, that the people are not paying as much not paying much attention, and so you do need to put in maybe measures of ambiguity, etc. But that's a separate topic. I think the main thing is go for it. Collecting human data is easy now. I think the thing that we should have done is, we didn't think about, our objective was to get the quantitative data, the ELO ranking of our statements. The AI thing came afterwards. And so we didn't do the AI, we didn't think about the AI test until we were already starting to do our priority was the human ranking. And then we realized that since we'd done this, we could compare it to the AI. I think if we'd done the AI first and regarded that as a simulation, that would have been a useful way to estimate how many participants we needed. Obviously, what we're doing is we're comparing these statements, and that's causing the ranking of the statements, the score given to the statements to sort of drift until they reach equilibrium. And we had kind of back of the envelope ways of kind of estimating equilibrium, but they weren't very good. And so we didn't really have any idea how long it would take for the data to reach equilibrium. And I think maybe doing the AI study first would have. So we were interested in comparing the human to the AI, and that's what we did. But what we didn't do was also consider the AI to be a simulation of the human experiment and use that as a tool when designing the human experiment. And if we were doing it again, that's, I think, what we'd do. Any other headline?
No, I think I'd say one of the useful bits on Prolific is that you can, continue adding more participants later on. So it kind of feeds into the idea of if us using the AI as the simulation, that although we felt like we'd finished running our human participants, we then did check with the AI that we felt like we'd got to a stabilization point, and we were able to continue running the AI, obviously, like a lot easier, a lot faster, to just confirm that was the case. But we could have very easily reopened up the study and gathered more.
Yeah, I think that's
if we needed.
I think we do have a mindset problem. Since we're used to psychophysics, we're used to the idea that you must always fix your number of participants beforehand and never change it. Because of course, if you're doing psychophysics to test for an effect, it's important to predetermine your participant number to prevent you p-hacking or whatever. But since actually what we're doing here wasn't that, we were using the participants for a task, not we weren't we had the participants we were testing, the people who did the original psychophysical test, and then we were using the second generation of people, as it were, to actually kind of do analysis for us, to turn the statements into numbers. And there's no issue with p-hacking them. You just get enough of them to do the thing that you want them to do. So I think, because we're coming from like a cognitive background in this context, we did think about that in the wrong way. And we were quite slow to think about reopening the original human participant activity, the ranking activity, after we did the AI. But of course, there was no reason why we couldn't have done. But that's just us. We were coming from a psychology idea of how you run experiments, not a science one.
That is really interesting, because it is something we've seen in the inverse when we have people researching AI coming to us and trying to get human feedback, they actually would request features like that. You can add more participants. You can let participants do the same evaluation task twice. Whereas us coming from an academic background is something that academics wouldn't have considered or requested. So it's interesting.
And I think it's just us thinking about it the wrong way. We're not testing the humans, we're using the humans. So it's fine. It's fine to reopen it.
I mean, we also didn't really have any idea how many we would need from the start, because we didn't know if it would work, firstly, and it did very well, luckily. So it was important that there was that kind of ability to be able to keep recruiting more once we thought that we got to a point where, okay, this is the right number of participants.
I mean, those tools generally for excluding or including particular participants have been useful to us in the past, because we ran these 3 studies and it was important, because we ran a version and then we changed the maze slightly or changed the questionnaire slightly, and it was important that we could exclude the people who'd done the first version from the second version. So that's something that's certainly very useful. And Kimberley has done one small pilot, a longitudinal study with multiple day participants as well. And I had another student who was doing a memory and affective states study. She did a whole series of studies in Prolific, and that was a longitudinal. It was across a couple of days, and it was important to be able to stick with the same participants, basically. That's a useful aspect of the Prolific suite of tools.
And to be able to contact them.
Yeah, hassle them. Please do the next day. yeah, for sure.
Nice. Well, thank you both so much. Can I get a quick sense check of where you're at with the research, if anybody is watching or is reading the case study later on and wants to check in and see, is there a paper coming or anything?
So there's I mean, obviously there's 2 sort of slightly separate bits of work now. One is the relationship between the AI and the human ranking.
And then the rest is my thesis, which I am in the process of writing up.
Yeah, so that bit has appeared as a late-breaking work with CHI. What does CHI stand for?
Computer-human interaction.
Yeah, so it's the big HCI conference. So that has already appeared, basically. And then the actual interpretation of these experiments and the use of the data, that analysis is still ongoing, will form part of Kimberley's thesis. So when are you submitting?
Soon.
Kimberley does have a job for afterwards, so she needs to get everything wrapped up soon. And hopefully a paper will come out of that as well, but concentrating not on the comparison with the AI, but just on the use of the data, the original psychophysical study, which we ran through Prolific, and then including the quantitative ranking of the significant events.
And if you go to the paper, we have also made the data and the code open access via GitHub.
I mean, I think it's quite an interesting, I mean, it's only 350 statements, but it's still 350 life events gathered in this reasonably ecological way. So, if you are interested in the evaluation of, the effective weight, the significance of described events, it's 350 statements. It might be useful for people.
Definitely. Amazing. I will include that wherever we publish this. And if there's nothing else either of you would like to add, I'll just say thank you so much.